graders, welcome to your next math virtual learning lesson. Just as a reminder, make sure you're ready to learn. Find a quiet place to do your work, have your pencil and math notebook out, and message your teacher if you need help. Let's get moving with today's warm-up. The directions say multiply. Write your answer in simplest form. So this is a review of what we did in some previous lessons. Go ahead and pause the video, work out these 4 problems, and then hit play when you're done. All right, let's take a look at number 1. 1/4 times 12. Remember that 1/4 times 12 could also be read 1/4 of 12, because when you take a part times a number, it's the same thing as taking a part of that number. So let's work out 1/4 times 12. I'm going to keep 1/4 as it is, and then I need to change the whole number to make it a fraction. To do that, I place a 1 as my denominator. So 12 becomes 12 over 1. Now I want to multiply my numerators and then multiply my denominators. 1 times 12 is 12, and 4 times 1 is 4. So we get 12/4, but you always have to ask yourself if you can simplify that. Fractions are another way to write division. So 12/4 is the same as saying 12 divided by 4, and that gives you 3. So 1/4 times 12, or 1/4 of 12, equals 3. Did you get it right? All right, good job. Let's go to the next problem. All right, for this one, we have 2/5 times 15. I'm gonna do pretty much the same thing. 2/5 times 15 over 1. Very good. I'm going to multiply straight across. 2 times 15 is 30. 5 times 1 is 5. And just like number 1, I want to remind you to simplify. 30/5 is the same as 30 divided by 5. 30 divided by 5 equals 6. So 2/5 of 15 equals 6. Hopefully you got that one right too. All right, number 3. All right, so now we're looking at multiplying a mixed number times a whole number. And if you can recall, you have to do something to that mixed number before we can multiply it. Let's see if you remembered what to do. 4 1/3 times 3. So, did you remember to change 4 1/3 into an improper fraction? Here's how we have to do that. 3 times 4 is 12, and 12 plus 1 is 13, and we keep 3 as our denominator. So 4 1/3 is rewritten as 13/3. And did you remember what to do with that 3? Make it a fraction by putting a 1 underneath. So it's really 3 over 1. Now I'm going to simplify the problem because I noticed my diagonals, or at least that diagonal, has the same number. That makes things nice. So each of those 3's can cancel out and become a 1, because their GCF is 3, and when you divide them both by 3, you get 1. Now this is really simple. 13 times 1 is 13. 1 times 1 is 1. 13 over 1 is 13. So 4 1/3, 3 times, gives you 13. How'd you do on that one? That one was a little tougher. All right, and let's look at our last warm-up problem. 1 3/4 times 2. Very similar to the problem we just did. What do you have to do with 1 3/4? Yep, you have to write it as an improper fraction. 4 times 1 is 4, plus 3 is 7. Keep your denominator 4. So 1 3/4 is the same thing as 7/4. Now we multiply it by 2 over 1. Very good. In this problem, I can simplify my problem and then multiply, or I could multiply and then simplify my answer. I'm going to simplify the problem again because I know that can be tough for some people, and I'll just give you another chance to practice. When I look at my diagonals, I can't do anything with 7 and 1. Their GCF, it would be 1. So there's nothing to do there. But 2 and 4 can both be divided by 2. So what's 2 divided by 2? 1. And what's 4 divided by 2? 2. 7 times that 1 gives me 7. And 2 times 1 gives me 2. So 7/2 is almost my answer. We have to turn 7/2 into a mixed number. How many 2's can I take out of 7? 2, 4, 6, 8 is too many. I can pull 3 groups of 2 out of 7. That's my whole number. When I pulled 2 groups of 3, that was 6. 2, 4, 6. So what's left over? I had 7, I used up 6. 1 is left over, and I keep my denominator. So if I have 1 3/4 twice, I get 3.5. How'd you do on that one? That one was probably the hardest for you because you had to take what you thought was your answer and rewrite it as a mixed number. All right, so now that you're good and warmed up, I think you're going to like today's lesson. It's a little different from some of the ones that we were doing. I taught you how to multiply whole numbers and fractions, fractions and fractions, and then we work with multiplying with mixed numbers. Today, what we're going to do is something a little different. So here's our objective. I will be able to interpret multiplication of fractions as scaling. This is lesson 10.8. This is a hands-on lesson, so it's going to be set up a little bit differently than we're used to. I want to go over the word scaling first because this may be a word that you've heard in different places, or maybe you've never heard of it at all. So what is scaling? Let's zoom in here so you can see. Multiplication as scaling. Scaling is a word that you might hear in other areas. When I hear scaling, sometimes I think of someone who climbs a mountain can be said to be scaling a mountain. But in math, it means something different. In math, scaling is the process of resizing a number by multiplying it by a fraction that's either greater than 1 or less than 1. So what does this really mean? Well, think about if you've ever taken a picture and you wanted to make it larger. Okay, so I know you guys probably don't have pictures that you print out because you're in the tech age, but I still do print pictures. And my sister will send me pictures of my nieces and nephew, and she'll send me the little tiny wallet size. And I like to put them in a nice big 5x7 frame. So what I do is I enlarge that photo. I take it to usually CVS and they have a photo center, and I put the picture down on the screen and then I enlarge that photo. I'm resizing it, okay? I am making that photo larger. I'm scaling it up. That's one of the ideas that we can think of when we talk about scaling, okay? We're resizing something by multiplying it by a fraction that's either greater than 1, which would be a mixed number, or less than 1. So let's take a look at this. Like I said, this is a hands-on lesson, so it's going to be set up a little differently. Our first task is to multiply the number 2 by 3 fractions that are greater than 1. What do we call fractions greater than 1? Mixed numbers. Very good. So let's take that 2 and multiply them by 3 mixed numbers. So the book has chosen to multiply 2 by 1 1/5, 1 1/2, and 1 3/4. And let's see what we get. So I'm going to do this work for you. 2 is going to go as 2 over 1. And then I need to change 1 1/5 into an improper fraction. 5 times 1 is 5, plus 1 is 6. Keep my denominator. 2 times 6 is 12, and 1 times 5 is 5. Now I need to put it back as a mixed number. But think about it. Is 12/5 more than a whole or less than a whole? It's more than a whole because the numerator is greater than the denominator. So we know it's more than 1. How many 5s can we take out of 12? 5, 10, 15's too high. I can take 2 5s out of 12. And what's left over? 5 times 2 is 10. 12 minus 10 is 2. So when I took 2 times 1 1/5, I got 2 2/5. Let's do the next one. 2 is going to become 2 over 1. And 1 1/2 has to be turned into an improper fraction. 2 times 1 is 2, plus 1 is 3. Keep your denominator. Ooh. Oh, goody. I noticed something nice. One of my diagonals has the same number. So those 2's can cancel out and become 1's. 1 times 3 is 3, and 1 times 1 is 1. So this equals 3. Ooh, sorry. Ugly line there. All right, let's do the last one. I'm taking 2 times 1 3/4. 4 times 1 is 4, plus 3 is 7 over 4. If I check this diagonal, I can simplify 2 and 4, divide them both by 2. 2 divided by 2, 4 divided by 2. 1 times 7, 1 times 2. How many 2's come out of 7? 2, 4, 6, 8 is too high. I can take 3 2's out of 7, which was 6, and that leaves me with 1 left over. So I have 3 1/2. All right, so notice we're looking for a pattern here. So notice that when I take 2 and I multiply it by mixed numbers, look at my answers, and we're just going to start to notice a pattern here. Let's plot 2 on the number line, and then plot those products, those answers we got on the number line. Well, 2 was done for us. Let's use red for the first one. Here's 2, okay? The first product that we got was 2 2/5. So 2/5 is not quite half, but it's almost half. So we're going to put it about right here. That's 2 2/5. And then we got 3 when we multiplied 2 by 1 1/2. And then we got 3 1/2. Okay, so that's the 2, and those are the products in the different colors. So now let's make some comparisons. When we compare the products, circle whether the products, that would be the red, the green, and the purple, are greater than, less than, or equal to 2. Well, here's 2. Are they greater than 2? Are they less than 2? Or are they equal to 2? They're greater than 2. Why? Because multiplying a number by a fraction greater than 1 aka a mixed number, results in a product that is greater, oh boy, that's ugly, than the number. So what does that mean? If you take a number and you multiply it by something more than 1, that is the product is going to increase. It's going to be bigger. Okay? And just think about it. What's 2 times 3? More than 2. What's 2 times 10? More than 2. So anything greater than 1, if you multiply it by a number, it's going to increase. All right, let's look at the next page and we'll see another idea. Multiply the number 2 by 3 fractions that are less than 1. Think about what might happen here. Compare it to what we just did. So let's take 2 and multiply it by 3 fractions. 2 times 1/4. A little easier here. 2 times 1/4. Notice I put a 1 as my denominator for 2. 2 times 1 is 2. 1 times 4 is 4. Think about what that would be simplified. What's 2/4 simplified? Yep, 1/2. Good. All right, now let's do the next one. 2 times 1/2. Here's my 2 times 1/2. Oh, diagonals that are the same. We love that because they can both become a 1. Look at all 4 of these are 1s. So what does that equal? 1. Very good. And lastly, 2 times 5/8. 2 times 5/8. 2 times 5 is 10. 1 times 8 is 8. Okay, how many 8s can you take out of 10? Take out 1. When you take 8 away, what are you left with? 2/8. That can be simplified. Yep, down to 1/4. All right, so we got products of 1/2, 1, and 1 1/4. So let's plot all of that on the number line. Here's our 2. They've already plotted it for us. Now let's plot the products. First one we got was 1/2. That's between 0 and 1. The next product we got was 1. And the last product we got was 1 1/4. Right about there. So compare these products. Are they all greater than 2? Are they all equal to 2? Or are they all less than 2? They're all less than 2. Why? Because multiplying a number by a fraction that's less than 1 results in a product that is less than the number. So let's think on it. Let that soak in. Now make a prediction. Think about and predict whether the product of 3 times 4/5. So let's write that out. 3 times 4/5. We're taking a number and multiplying it by a fraction less than 1. Well, is that answer going to be greater than, less than, or equal to that 3? Think about it. All right, if you thought that that product is going to be less than 3, you are correct. It's less than 3 because my fraction that I'm multiplying by is less than a whole. Think of it this way. Remember how I said multiplication, when you have a number times a number, you can say of? If we said 4/5 of 3, we're taking a part of 3. So that means that that part has to be less than 3 because we were taking less than what we had. I know that sounds a little confusing. Let's do another one. Predict whether the product of 2 and 1/5 and 2, sorry, I kind of mixed that up. Predict whether the product of 2 and 2 and 1/5 is greater than, less than, or equal to that 2. So there's 2 times 2 and 1/5. Will the product be greater than, less than, or equal to 2? It'll be greater than. Why? Because we're taking a number and we're multiplying it by a fraction greater than 1. 2 and 1/5 is greater than 1. So that's like enlarging a photo. We're making it bigger. Whereas the one above that we just did, we were reducing that photo. We were making it smaller. All right, very good. All right, we're gonna play a little sorting game to help you remember if it's greater than or less than a whole. So I have a couple of problems, and you can't do this game, but you can help me out. And I want you to think about it. So we're going to take one of these little cards and drag it into either the less than whole or greater than the whole. So let's look at this first one. 2/3 times 5. I want you to think, will that product be less than 5 or greater than 5? It'll be less than 5 because we are reducing it when we resize it because our fraction is less than 1. How about this next guy? 2 and 1/7 times 6. Is our product going to be less than 6 or greater than 6? Think about it. If you said greater than 6, you're right, because we are enlarging that photo than a whole. All right, next one, 3/4 times 3. Is that going to be less than 3 or greater than 3? Less than 3, because we are taking a fractional amount of the 3 that's less than 1. So you can see the pattern. If your fraction is less than 1, your whole number will decrease in our product. If the fraction is greater than 1, we enlarge it, we make it bigger, so it increases. How about 1 and 9/10 times 4? Yep, it's a mixed number, it's greater than 1, so it's going to be greater than that 4. How about 6 times 3 and 6/7? Greater than the whole. Very good. And there's one guy hidden back here. Let's see. 3 times 4/5. Where should he go? Where should he go? Less than a whole, because we're multiplying 3 by a fraction less than 1. Woohoo, blast off. All right, wonderful job with that. If you'd like more practice, I'm going to display some more problems. And I don't know where my Zoom is. Zoom, where'd you go? There we go, okay. So I'm going to display more problems. You can pause this and copy them down. The directions for these say without multiplying them. Figure out if the product is greater than, less than, or equal to the whole. So same thing we just did. Okay, here are more for you to practice. And then we have some problem solving. Remember, you can pause and practice these. Message your teacher if you have questions. I love these which one doesn't belong. All of my students know that those are like my favorite problems. And just remember that when you're answering the question, you might be able to find more than one that doesn't belong for various reasons, but always try to think about which one doesn't belong based off of the lesson that we just did. All right, well, that concludes today's lesson. As usual, if you need more help, please ask your teacher, but also rewatch the video. Go to a place where you were struggling, watch it a few times. You can always then message your teacher, but try to watch it at least twice before you say, I don't get it. Okay? And we'll see you again soon. Stay healthy.